In this video, I will demonstrate the rotational symmetry, order of rotational symmetry for some basic 2D shapes. Here we've got a square and I have made the mark A at this corner to face this A here from the space in which I have cut it out from, and we're going to see how many times I need to turn the square for it to fit exactly back into that space. Yeah, so I'm going to turn it. It has 4 sides, so it makes sense to try to turn it about 4 times. So I'm going to turn it the first time, and my A is on the first corner after the starting point, and it fits into that space. So I'm just going to try to, it fits well. A second turn, and it fits into the space. A third turn, and it fits into the space, and finally back to its original position. So I was able to turn it 4 times, so it has an order of 4 rotational symmetry. What about a rectangle? So we have a rectangle there, and I have my A facing A, the starting point. It has 4 sides, but they're not all equal. I'm going to turn it the first time, and it's so obvious that it doesn't fit. I turn it the second time, and it does fit. If I turn it the third time, it doesn't fit, and then finally the 4th time back to its original position. So I was able to turn it twice to fit 180 degrees, half a turn this way, upside down. That's not its original position, and back to its original position, making 2 turns to go back to its original position. So it has an order of 2. What about a parallelogram? So that's our parallelogram, and I have marked my starting point A at this corner there. Again, it has 4 sides, so I'll attempt to turn it 4 times. So this is the first time, and it's too obvious that it doesn't fit. The second time, it does fit. You can see my A is upside down, and it fits into the space. So that's one fitting. A third time it doesn't fit, and the 4th time. So again, it fits twice, one upside down and back to its original position. So we say a parallelogram also has an order of 2, rotational symmetry, order of 2. Let's have a look at a rhombus. A rhombus is similar to a parallelogram, just like a square is similar to a rectangle. So a rhombus is a kind of parallelogram which has all 4 sides equal. However, not all the 4 angles are equal. 2 opposite angles are equal. So I have marked my point A over there on my rhombus. I'm going to turn it 1/4 of a turn. It doesn't fit. Upside down, it does fit. So that means it also has just 2 order of rotational symmetry as well. So a rhombus has an order of 2. So let's have a look at the triangles. A triangle has got 3 sides. So I've got an isosceles triangle here. I've already written order of 1 because it doesn't fit in any other way apart from the starting point. If I try to put this angle here, it will not fit. And if I try to put it here, it doesn't fit. It has to go back to its original position. So it has an order of 1. And I'm going to try an equilateral triangle. There. So it does fit in the original position. Again, if I turn it, it does fit there on that corner. And if I turn it to the 3rd corner, it does fit as well, and back to the original position. So 1, 2, 3. So it has an order of 3, rotational symmetry. What do you think about a circle? What order of rotational symmetry do you think a circle will have? Now I have this cover of a jar, which it will fit as many times as possible into the little, waves, as many times as they are there, which will be a lot to count. But what about a circle which is all the way around? How many times do you feel it will fit? So that is a question to think about.